Ladies and gentlemen, welcome everyone. I am Dr. Roland A. Drolet, PhD in Biomedical Engineering from the University of Toronto, 1971. I am the developer and inventor of the RUMART PEM system that has helped over 1 million people all over the world who were suffering from all kinds of health problems. I'm pleased to have François as my son François, who has won a gold medal at the Olympics in Japan, Nagano, in short track speed skating in 1998. So I'm pleased to tell you a little bit about quantum mechanics. I'm not expecting you to take all the equation and my words for granted, but this is the third clip in the introduction of quantum mechanics, and it relates to really the understanding and the documents of a Nobel Prize Richard Feynman, who was what I consider probably the best pedagogue in teaching physics. Okay. It has 3 big books. If you look in my shelf over there, Tome 1 and Tome 2, Volume 1, 2, he has 3, and one of them is on quantum mechanics. But this guy has simplified a way of calculating what happens when 2 electric charges, let's say of opposite sign, hit together, okay? Positive and negative charge, they attract, okay? And the force of attraction is inversely proportional to the square of the distance. So when the distance becomes near 0, the force would be infinite, okay? So what happens? In reality, the force doesn't come infinite, but somehow their energy, their mass energy, or energy of mass of the positive and negative charge, if they have the same mass, will hit together and disappear and give birth to 2 gamma ray photons, for example. Okay? So matter will be converted into photon, pure electromagnetic energy. And if you have 2 photons hitting each other, okay, of the same amplitude, let's say, they can give birth to matter and antimatter. What is matter and antimatter? The antimatter, defined by Dirac, the first one who solved an equation that in which it seemed that the solution was showing that there could be matter and antimatter, in the sense that with the same mass and opposite charge, and that these, when they hit each other, would be converted. So he decided that matter could exist because the equation gave this possibility. But mathematics can give any possibility that is not necessarily realized physically. So he arrived at this conclusion, I think 1 year or 2 years before antimatter was first realized, in just looking at cosmic ray when they get into a chamber, what do we call the Wilson chamber, with oil bubbles, you know, and they call it the Wilson chamber. I don't know the exact details of this, but when the X-ray gets in there, it's so much energy of photon and accelerated charge that it creates all kinds of particles. And they observe in this photographing this that there were in a magnetic field, they apply the magnetic field across this, and you know one of the equation, an electric charge in a magnetic field will go around. Okay, so they realized that there was one particle with the same mass of the electron going around in one direction. There was another one always of the same radius of orbit going in the other direction. So that meant from the theory that there was not only negative electron, but there was positively charged electron with the same mass. And this was the realization that antimatter is not just a theory from mathematics, it exists really. And after that, in the, I would say, 2-3 decades following that, it was discovered that all particles have their antiparticle, protons and antiprotons, and some, like the photons, are their antiparticle because they don't have charge. So you cannot talk about positive, negative. Neutron also, since it doesn't have electrical charge, it's antiparticle. But any electrical charge has an antiparticle. And as I was explaining to Dennis a few minutes ago, when there was that Big Bang at the beginning of our universe, about 13.7 or 13.8 billion years ago, okay, when there was this huge explosion giving the universe that we know today, there must have been, and this is predominantly matter in our universe, okay? And there is just a little antimatter that of some cosmic ray that we see, and we can produce them in labs. But the huge majority, let's say 99.99%, is matter. There is not much antimatter. But when you create matter with photons hitting each other, there is always antimatter created. So somehow, when this Big Bang created this universe, there must have been another universe created of predominantly antimatter. So from the laws that we know in physics. So I explained to this because you can understand that. Now let's show you the mess of mathematics that is not using complicated mathematics, but just the quadratic solution of an equation that you learn in high school. Okay, this is about induced magnetic alignment by a magnetic field. Okay, this is my page 14. The orbital magnetic moment of an electron on the nth orbit of the hydrogen atom, Bohr's model. The magnetic moment on the nth orbit will be n times, n being the quantum number, the Bohr magneton. Know that we talked yesterday, and the Bohr magneton has this value. I know that you remember that. This is an ampere square meter, okay? Ampere multiplied by square meter. So we know that there is a little equation in classical mechanics that says that the alignment, momentum of alignment with the magnetic field of the little magnet perpendicular to the magnetic field of the room multiplicator, for instance. If we hold the magnet so that the field of the little magnet is perpendicular to the field generated by the ring, they will have a little torque. And this alignment momentum is given by the magnetic moment times the external field. And if we apply this to Raman, okay, we know what's the magnetic field, the peak magnetic field. So these, let's say, millisecond time of impulse is very slow compared to what happens in atoms, okay? Because like an electron takes about 10 to the power minus 17 of a second to go one circle. So this is so many turns in 1,000th of a second. Okay, so for the atom, this is almost constant field. See what I mean, so to speak? So when the magnetic field, here I talk in Gauss, the unit of magnetic field in the MKS system is Weber or Weber per square meter. But usually in literature, the unit Gauss is used, okay, smaller unit. So it takes 10,000 Gauss to make 1 Weber per square meter, okay? Okay, so actually, if you have this alignment momentum is this value there, okay, multiplied by B in Gauss, okay, external field, okay, but the external field multiplied by the here it's like it's like 10,000 Gauss, okay? I calculated this, and with 13 Gauss, which is about the maximum field, peak magnetic field in Mach C2A, when the amplitude is at 10, with the rebound 4A could be 50 Gauss, or it could be 100 Gauss with mini 4A, and with the early mini, the big units that you saw in when you were 8 years of age, they could generate as much as 900 Gauss peak. Okay? So if you place this Gauss value there, you realize that, of course, depending on the number of the orbit number of the electrons, you will get the magnetic moment exerted by the Raumart system in electron volts, because 1 joule here is 1 electron volt is 10 to the minus 19 joule, 1 electron. It's an energy unit. So we place it in electron volt unit to avoid the minus 19, this kind of thing. We took a smaller energy unit that is in the range of energy unit of electron around protons, as compared to Earth going around the Sun. It is billions and billions. So here we can calculate the magnetic alignment force using different applicators, depending, of course, on the external field, yes, but just what is going to be exerted on electrons in the whole body, okay? So using different applicator, and this is simplified treatment with classical mechanics. But there is a more complex treatment in quantum mechanics, and this is in volume 2 that I showed there about Raumart paradigm, but it's somehow beyond the scope of this introduction. So that's the end of this clip. Thank you for your attention. I hope you enjoyed it. And please keep smiling till the next clip.